Okay guys, we are now talking about graphing absolute value functions. This sort of graph is also called V graph. That means this is due to the shape of the graph. Shape usually is in V shape, therefore it is also called V graph. Okay, so I will first start with graph 1. Graph 1 for the function y equal to modulus of x. So let's see here. This modulus of x is two equations. One equation as y equals to x when x is greater or equals to 0, and another equation is y equals to negative x when x is less than 0. So let's see here. We shall take one rectangular axis and then we can see how it can be done. So here I'm drawing a graph. Okay, so along this it is x-axis and this is y-axis. If you start from 0, it goes from 1 to ... it goes up to infinity to the right, plus infinity to the right. Similarly, towards left it will be negative infinity, towards up it will be positive infinity. You can also mark like this if you like, 1, 2, and so on. To the left you have negative 1, negative 2, negative 3, and it runs up to negative infinity. Similarly to the down, it is negative 1, negative 2, etc. up to negative infinity. So in this case, if you have look at this equation, you can see that this is the equation of a straight line y equal to x, where its gradient value is here its gradient value m is 1 and c is 0. Here in this case its gradient value is negative 1 and its c value, that is y-intercept, is 0 when you compare that with y equals to mx plus c. So if I'm talking of this line y equal to x, my graph will be of this type. So this would be the equation of a straight line whose graph is y equals to x. Now similarly, if you go down to the third quadrant, you can see that this line is still y equal to x, but for less than x, y is also negative when x is negative. So you can see like this. And then if you go to another equation, y equal to minus x, that means if you talk about y equal to x, its gradient is 1, that means it has got the acute angle gradient. Acute angle gradient means that is less than 90 degrees. So its gradient angle is always acute about the positive x-axis. What about this? If you see m equal to minus 1, that means its gradient is definitely the obtuse angle, that is greater than 90 degree. So that will be this way. Okay, so here in each case you can see y equals to minus x, and if you see about this, if you measure this angle about the positive x-axis, you will see that this is obtuse angle. Okay, so that way we'll have a graph of V shape. Why it is V shape? Because one time we have to take positive x when x is greater than 0, another time we have to take negative x when x is less than 0 by definition of absolute value function. So the graph is ready now, but you don't need to write all these things in your main working part. So this I'm doing in order to let you understand how the graph is plotted for this kind of equation. So in your working, you can just simply write it down here. Say it is x-axis and it is y-axis. Towards x-axis towards the end, it is positive infinity. Towards the positive x-axis, along the positive x-axis, the number goes up to positive infinity, and similarly opposite of that is negative infinity, and the opposite of this y-axis below 0 is negative infinity. So you can simply write here like this graph is for y equal to x, and then another graph, make a nice figure, y equals to minus x. So whole graph is about the function y equals to absolute value of x. And while doing this, you should also be able to analyze that, how you take this. For example, you have drawn y equal to x, and another equation is going to be y equal to minus x. That means y equal to x, and if it becomes y equal to minus x, so this line will reflect about the y-axis, and it will go towards the second quadrant, and hence this line is obtained. Okay. Now, next one is, I'm going to draw another graph. For example, you say you have got y equals to minus absolute x. Then in that case, what you can do, instead of doing a lot of things, you can just write it here, and then you can draw the graph for that. And in that graph, you know that this is x-axis, this is y-axis, this is 0, and graph of y equal to absolute x is like this. So graph of y equal to absolute x is like this. Just now we have seen here. And you can see that this is minus, this is negative sign of absolute value of x. That means if you are going to draw the graph for this, it is going to reflect about x-axis. So reflection about x-axis means it will move down to here. So this line, reflection of this line about the x-axis is this way with the equal angle, and reflection of this line about the x-axis is this way. Okay. Yeah. So in this case, you can see to the down, this is the graph of y equals to minus absolute value of x. Now, what if we talk about the range and domain? So range and domain of this function is here it is for this function, domain for this function is, you can see domain for this function is like x has, so if you take value 1, 2, 3, 4, 5 up to plus infinity, and similar step towards the negative infinity, what happens? This graph will go along this positive and negative infinity of x, and similarly it will rise about positive infinity of y. So x can take value negative infinity to positive infinity. So this is the domain of the given function. What about the range? If you talk about the range of this function, so range will be, you can see here, range means we count along the y-axis. So here the range, the minimum value of y is 0, and maximum value will go up to plus infinity. So it will start from 0 less or equals to y less than plus infinity. So range of this function is 0 to plus infinity, and domain is negative infinity to positive infinity. So what about the range of this function? Sorry, domain of this function first. So here, domain for this function is, this function means I'm talking of minus absolute value of x. Can you guess? Yeah. In this case also, domain will be from negative infinity to positive infinity, and hence we can write negative infinity less than x less than positive infinity. So you can see the green line here, and this is the main graph, and range for this function in this case is, range is, what is the range? It starts from 0 and goes to negative infinity, and towards up it is positive infinity of for y-axis. Okay. So all y will be less than or equals to 0 and greater than negative infinity. So in this way, you have range as negative infinity to 0, and domain is negative infinity to positive infinity for this function. Also, you can see other feature of this graph, like y equal to minus x. What does it mean? It gives you two facts: y equals to minus x when x is greater or equals to 0, and that is going to be minus x when x is less than 0. So let's rewrite this: y equals to minus x for x is greater or equals to 0, and this is x for x is less than 0. So here you can see that if you talk about y equals to y equals to minus x, so this line is y equals to minus x. Okay, so this is y equals to minus x. So this line y is minus x for x is greater than 0, and here y equal to x. sorry, yeah, y equals to minus x means this. So this is the part. So this part exists for x is greater than 0. And if you see here x y equal to x, that means we are talking of this line. So in this graph we are talking of this line. So here in this case we have y equal to x. So this is the equation of y equal to x for x is less than 0. That means when you go to the value of x lesser than 0, it will give you this line. Therefore you can see here that when in this case when y equal to 0, so y equal to 0 is defined for x is less than 0. All right. So in this way we can draw the graph of absolute value of x and negative value of negative absolute x. So what is the difference between these two? So this graph is v towards v to the upside of x-axis, and this is v towards downside of the x-axis. So that means this graph has been obtained by reflection of the first graph about the x-axis. Okay, now see the graph of the function like this. So it is y equal to absolute value of x plus minus 2. So there are two functions, one with plus 2, another with minus 2. So first of all, I talk about y equal to absolute x plus 2. So I have drawn the axis. In that case, you can use the strategy that we have learned in transformation of the graph. So here, first of all, I'm taking the graph of y equal to absolute value of x that I have discussed earlier. So here in this case, in whole x, 2 has been added. That means the graph will move 2 units up, and our graph starts from here with the same shape of the graph. So finally it is y equals to this is the graph for y equal to absolute x plus 2. In that case, if you want to discuss the domain and range of the given graph in this color, so here you can see as you go up from 2 towards along the positive y-axis, then what happens? X will keep on extending towards negative from both the sides, towards the infinity from both the sides. That is towards negative infinity to positive infinity. Therefore, domain for this function is negative infinity to positive infinity. But about the range, if you talk about, so it starts from y equals to 2. That is minimum value of y is 2. Therefore, its range will be greater or equal to 2. Greater or equal to 2 means y will start to move from 2 towards infinity. And this can be also written as 2 less or equals to y less than 8. 2 less or equal to y less than infinity. Okay. I'll now talk about in place of plus 2, if I write minus 2, then what happens? There will be the same strategy, but the things will be in opposite direction in this case. So instead of moving upside, because y is 2 has been taken from y, so for minus y, it will move 2 units down from this origin point, and it will reach to minus 2. So your graph will look like this. In that case, if you talk about the domain, there is still not changing domain, because as you rise from this negative 2 value, then x will rise towards negative from both the sides. So it has the same domain, but the range has now changed, because in the previous thing range has started from 2, now it starts from negative 2. So the minimum value for y in this case is minus 2, and this can also be written as minus 2 is less or equals to y is less than infinity. What happens when you multiply the given function by 2? So here we have multiplied this given function by 2 from outside of this absolute x. That means we have multiplied by some number in the y quantity. Y quantity means, and in the transformation of graph, you have already learned that if this number is greater than 1, the graph will go nearer and near to the y-axis as this number increases from 1. So this graph lies even near to the y-axis than the graph of y equals to absolute x. So in this case, if you talk about domain and range of the function, it looks like this. So you can think and analyze to check whether or not this is the domain. And the range, if you see, the value of y starts from 0 in either case. So for this case also, the range will be 0 to infinity. Now in pink color, this is the graph of function y equal to half times absolute value of x. Here you can see the value half is less than 1. Here 2 is greater than 1. So in that case, as you have learned in transformation of the graph, that when you multiply by the number which is less than 1, then it goes away from this y-axis than the original graph y equal to, here in this case, y equals to absolute value of x. Then can you talk about the range, domain and range of the function? So here I'm not writing actually, but you can write it if you like. Its domain is just still negative infinity to positive infinity, but range is 0 to plus infinity, because the value of y starts from 0 and moves towards infinity. Let's check whether or not this graph is correct. So we can use any kind of graphic software. So at this time, you can see here, like if you like to draw, check this. Actually, it is not allowed in your A-level exams, but for your confidence, you can sometimes, and for some graphs, you can check in order to verify that where you are in the right path. So first of all, because I started the graph by using first of all only absolute x, therefore I will try the graph for absolute x. So here the graph for absolute x is, I put absolute sign here and x, and then yeah. So this is the graph for absolute x. You can see it clearly. Okay. Now you can note the color in the index. It is different in different calculators, but whenever you plot more than one function on the same graph, it will give you different color. So you note it down to the color as well. Now we are concerned to write the graph for 2 times of the absolute x. So I'm writing 2 here, then absolute sign here inside x. It has now different color, that is saffron. It looks like saffron. So here you can see here in the saffron color there is 2 times of 2 times of absolute x, and this dark color is for the absolute x only. So you can see as you multiply by the number greater than 1, that means it is more towards the y-axis than the original graph y equal to absolute x. Then what happens when you plot the another graph which is in the pink color here? I hope you can see it now. A little bit dark it was. Okay. So I'm typing here now 0.5. You can also write 1 by 5 and absolute value of x, and absolute value of x. So half times absolute value of x is away from y-axis than the original graph y equal to absolute x. So here in my figure it is represented in the pink color. So you can see here by using the graphics software also our graph is correct. That means when you multiply by the number which is greater than 1, it will go more and more towards y-axis as the number increases, and it will go away from the y-axis when the number goes down to 1. Okay, and that can be compared with the original graph. That can be compared with the graph we have drawn to draw other graphs. So that explains that how to draw the graph of such kind of function. So let me display it for you. Now how about drawing the function of this kind? So we drawn this kind of function. So now we shall try to draw another kind of function. For example, say it is y equal to absolute x plus 2 in this case. So here also you can use the strategy of transforming the graph. So here we take x-axis and y-axis. Now we have different strategy to do the graph. So first of all, I'm taking the strategy of transforming the graph. So first of all, take the graph of y equals to absolute x. So this is the graph of y equal to absolute x. But in this case, what you can see here, when something is added to x, it will go 2 units left along y-axis. If you to do it minus, then it will shift 2 units to the positive along the positive x-axis. So here we are talking about this graph. So how you find that point? Actually, we can see here when you put y equals to 0 in y equals to x plus 2. I'm taking positive sense first of all. So it will give you 0 equals to x plus 2. That means x is negative 2. It means the graph has shifted to the negative side. So instead of starting from this point 0, it will start from x equals to 2. That is, this point is 2, 0. So what happens now? Another challenge is that where does it pass through on the y-axis? That means on the y-axis, you know that on the y-axis x equals to 0. Then if you use this equation, if you use this equation, then x equal to 0 means then y equal to 0 plus 2, so it is 2. So this point is going to be 0, 2. So we have one line this. Okay. Now let's suppose that the x-axis itself have been shifted over here, and then you can consider one line parallel to x-axis, and then you can see from here to here there is 2 units. So if you consider reflection about the line x equals to 2, you have to come 2 units left of this line. So up to here is sorry, it is negative 2. So up to here is negative 2 units. So another negative 2 unit will be here. Negative 4 units at the height of 2. That is on the y-axis. The coordinate is 2. So your line will pass through this. So this is the graph of y equals to x plus 2. What happens if you have graph of, first of all we talk about the domain of this graph. So you can see the domain of this graph is still from positive to negative infinity, or from negative to positive infinity in this case. So domain of this graph is in the entire range of the entire real number system. So x belongs to negative infinity to positive infinity. Then what about the value of y? So here range of the given function will be minimum value of y is 0 here, so it is greater or equals to 0. That means you can write y belongs to sorry, it should be the big bracket 0 to plus infinity. What if your function is y equals to x minus 2 instead of plus 2, or maybe 3? So 2 and 3 are not the matter. Actually matter is the signs. So here it is plus sign. Now we are trying for minus sign. So you can use this strategy that minus 2 in the x, that means it will shift towards positive x-axis, positive x direction, and it will go up till this point is 2, 0. So here in this case you can see, and at if you take y equals to x minus 2, and then if you put if you put x equals to 0, then if you put x equals to 0, then y will be minus 2. Y will be minus 2. If you put y equals to 0, your x will be plus 2. So this line is again going to pass through 0, 2. Now what about the another line? If you talk about the another line, like, so about here, if you talk about it should go to minus 0, minus 2 on the y equal to minus 2 when x equal to 0. Then your line will be here, but you have to draw a line parallel to y-axis passing through this, and this line will be x equals to 2. So if you use reflection of this graph about the line x equal to 2, your graph will look like this. So this is the graph of y equals to x minus 2. If you like, while practicing the graph, you can check in the graphic calculator. So let's check. So first of all, I will again type question. I don't know whether it is clear to you or not, but you try to understand how to draw the graph by using any graphic software. I hope you have a lot of idea about this. This is not necessary to check the graph, but this is important especially while you are practicing this, so that you will be even confident in drawing the graph. So first of all, I'm taking the graph of absolute x. So one function is absolute x, another function is absolute x plus 2, absolute x plus 2, and then I'm taking another function as absolute x minus 2. Now you can see in that graph in the red color is, you can see here, graph in the red color is for y equal to absolute x, and the graph in this color, you can see, I don't know, I can't see it clearly, but the color is different. So this point, if you see, this coordinate is minus 2, 0. That means when we have added 2, then the graph has shifted to 2 units back from this origin along x-axis, along negative x-axis. Now if you see this point, which is the vertex of graph of y equals to x minus 2, you can see as this is minus 2, it has been shifted to the right of 0 along the positive x-axis. So in this way you can draw the graph. Now do not stop to the single idea that I am usually talking to you. What you can do actually, you can see another strategy also to draw the graph. Like for example, I'm doing the same problem in another way. I'm doing the same graph in another way. So here I'm taking this function to graph y equal to 2. For a while, I would like to take y equals to x plus 2 for x plus 2 is greater or equals to 0 only. So here you can see, if you compare this equation with any equation like y equals to mx plus c, so you can see here m value is 1, that is the positive value 1. So it will give you acute angled graph. Yes, if that would be negative, that would give you the obtuse angle gradient. Acute angle, sorry, not the graph, acute angled gradient. So one thing we are sure that our gradient angle is going to be less than 90 degree on the first quadrant. And the c value is here. If you compare these two equations, c value is 2. That means the y-intercept is 2. Now let's check to draw the graph. So I will just plot here. I'll try to plot the graph here. So first of all, the gradient angle should be less than 90 degree. So our graph must be like this. No. Another thing is that our y-intercept is 2. So we start from 2. So 2 means here. So it is, this coordinate is 0, 2. So what happens here? So we take this angle. Okay. So if you compare angle of this line with the x-axis, it's going to be acute angle. And now you have to find another point behind this. So in that case, you have to search the point on x-axis. So at x-axis, okay, so at x-axis, the y is going to be 0. Therefore, x plus 2 is going to be 0. That gives you x equals to minus 2. So your another point will be, when it meets here, this point will be minus 2, 0. Okay. Now another step is that let's draw a line parallel to the y-axis passing through x equal to minus 2. That means this line is called x equal to minus 2. Now what you can see here, you can take some reference of this point. So from here to here, the distance is 2 units in the negative sense. So another 2 units in the negative sense will be here. So this point is negative 4 and height is 2. That means along y-axis, the y coordinate is 2. So in that case, your line will pass through this way. So you don't need this line. So this is the graph for y equals to x plus 2. Now, if you like, you can, in order to understand, in order to learn it, you can analyze this graph. So this is, it was x-axis, it is x-axis, and this is y-axis. How you can analyze your graph is that, for example, here you have y equals to x plus 2, and that will give you positive x plus 2 for in the case when you take x plus 2 as greater or equals to 0, and the same thing is going to equal to negative of x plus 2 when you take x plus 2 as less than 0. So what happens to this equation? In this equation, if I'm taking one step more, then I can see here this is minus x minus 2 in that case. So in the first case, if you see the gradient makes acute angle with the x-axis. But when you are taking this equation, that means your gradient is minus 1. It gives you obtuse angled gradient. So you can see here this angle is greater than 90 degree. Okay, so this way you can analyze the graph. And also for this graph, we can further take x as greater equals to -2. So that means this graph is valid for x is greater equals to -2. Okay, so if you take x is greater equal to -2, so greater equal to -2 means this is -2 value, this is -2, and if you move towards the positive x direction, in that case you can see that we have the graph of this function. So this line, if you are only taking it, is y equal to x plus 2. Now here, if you talk of graph of y equal to minus x plus 2, that means x plus 2 is less than 0. It gives you x is less than -2. So if you move along this line, you can see that every time x is moving towards the lesser value than this -2. So this way you can analyze your graph. So it's up to you that how you make your work easy and handy. Once again, I would like to reiterate that don't be stuck to the single idea. While learning, you try to see from different way. But in your examinations, don't be confounded in doing the same problem in different ways. So you should have a good practice before exam. Okay, so that's all for now. Okay, let's see now how to graph the function like this. This is y equals to -2 under the absolute sign, x plus 1, and then outside it is -3. So here also I can suggest you a number of ways that you can draw this graph. So first of all, I'll draw the graph by using the strategy in the transformation of graph. So first of all, I'll get my graph ready to draw. So it is x-axis and this is y-axis. You know, towards here it is +∞, and towards here it is +∞, and down to this origin along the y-axis, this goes up to -∞, and left of this origin along x-axis is going to be -∞. So if I am using the strategy of transformation, I think it's clear to see. Yeah. Okay. So now I will take first of all the graph of y equals to x. So here I'll take the graph of y equals to absolute value of x. Now you can see here as it is minus sign, so if that would be y equal to minus absolute x, then your graph would look like this. Your graph would look like this. Okay, so in that case you can see this is the graph of y equals to minus x. Now here you can see as 1 is added to x, then the graph will shift 1 unit to the left from this origin along x-axis. So your graph is going to here. In that case, your graph will look like this way. So this is the graph of the given function. Okay, so if I am considering only x plus 1, so when x equal to 0 on the y-axis, y is going to be 1, so it will pass through the point 0, -1. 0, -1 in that case. Okay, now so up to here we have the graph of minus x plus 1. Now you can see that it is multiplied by 2. That means we have to consider one line parallel to the y-axis, and if you suppose as if it acts like the y-axis, then for -2 it will be a bit closer to the line x equals to -1. So this point is -1, 0. So closer to this means your graph will look like this now. So when it is multiplied by 2, so when it is multiplied by 2, it will look like this, and this point, if you read in your graph, it should be when it is multiplied by 2, so this is -2, and towards on the side also it is -2, and this is 0 up to here -1, then up to here it is another -1, makes x as -2, and value of y will be also -2. So in that case your graph will be like this. Okay, so we have already worked for graph of this part. Now what are you concerned with? Because the place is not enough here, you can just extend this down to some extent, it is negative infinity, and then you can attempt to draw the final graph. So in the final graph, what happens? It is -3, so as the y is 0 here, so it will go through 3 unit down from this x-axis. So 1 to 3 unit, if it goes down to the x-axis, this point would be 3 units. So this is 0, so now it is y is x is still -1 and y is 3 units down, so this is -3. Then what about this point? This is 0, -2, so 0 still remains 0. Then it will be here, and 0, -2, -3 is -5, and in that case you have to consider another point also. So just about the equidistance from this line to the other side, to the left of this line, it is this gap is -1, so another gap must be -2, but the y coordinate here is -5. So your vertex will be -1 and -3, so that it is your graph, your final graph will be like this. If domain or range is not fixed, you can just extend your graph like this. So this will be your final graph. So in that graph, this is the graph for y equals to -2 absolute, x plus 1, and then -3 in there. So this is the final graph of the given function. What about if you think of domain and range of this function? So here from the graph, you can see that the maximum value of y is -3. So the range is going to be y is less or equals to -3. Yeah, less or equal to -3. So when you go down from this point, all the values of y will be lesser. So that will be in decreasing order. So here you can say domain of this function is going to be x. So here you can see as the value of y goes on decreasing, then from both the sides, x values will attempt infinity from both the sides. So domain of the given function is going to be -infinity to +infinity. And range, just now I had discussed that range is where the maximum value of y is -3. That means all the values of y will be less than or equals to -3. That is, also you can write like y belongs to -infinity to -3. Big bracket means it includes this in value. A small bracket means it is near to -infinity, but it doesn't include that value. Okay, so this is the final graph by using the transformation of graph. Okay, so this is one way to draw the graph. Now I will try another way to draw the graph. Let's see how to draw the graph in another way. So I'm taking the graph first of all. I'm taking the graph in the graph axis first of all. So this is x-axis, and this is y-axis, and this is origin, and we'll mark the point whenever we need. So now you can see here, like your equation is y equals to -2, x plus 1, and this is -3. So for instance, I'm taking y equals to -2, x plus 1 for x plus 1 is greater or equals to 0. Okay, so in this case, if you like, you can write one step more. So it is -2x and -2 when you multiply x plus 2 by -2. Okay, so it looks like as if it is y equals to mx plus c, where m is -2 and also c is -2. That means slope is -2, slope is negative. That means if slope is negative, the slope angle will be obtuse. That is, the slope angle will be bigger than 90 degree. And this is the y-intercept, that is the line cuts on the y-axis is -2. So first of all, I'll mark here 0, -2. Yes, and I have to search a point on x-axis as well. So in order to search the point on x-axis, what you can do is, like on x-axis, y value is 0. All of you know that. That means it will give you 0 equals to minus 2 x plus 1, and when you solve it, you will get x equals to minus 1. So we have searched the point on y-axis as minus 1 and 0. Now on the x-axis we already have this, so our line will be like this. Okay, so our line will be like this. Here you can see this line makes obtuse angle with the x-axis. So this is the equation for line y equals to minus 2x minus 2. Okay, so for x plus 1 is less than 0, you can also take y equals to minus 2, and that would be minus x plus 1. Then your line will become minus minus plus, so it is 2x plus 2. So as the gradient part is positive, that means it will make acute angle with the x-axis. So in that case, and also if you put x equal to 0, it's going to be 0, 2. So your line will be passing this way, another line. Okay, and you can extend the same line down from here. All right, and so this would be the graph of the function y equals to 2x plus 2, and this is the graph of function y equals to minus 2x minus 2, that way. Now we have to go to the final touch of this graph, because we did this up to here only. Now there is minus 3 in whole y value. That's why for it is minus 3, all the points on this graph will go 3 units down from 0. So 3 units down from 0 means it is going here, so its vertex will move to here. So it is x remains same, but it is going 3 units down, so it is minus 3. All right, and that will go to 0. 3 units down means if you add minus 3 to minus 2, that means it will be minus 5. And here to the left of this, you can better to draw a line of reference, so that it will be a line vertical to the y-axis, so that it will be easy to count. So it is 0 minus 3. So from here to here along x-axis minus 1. So by reflection about this line, other side will also be, so it is minus 1, so another minus 1 will make it minus 2. Okay, from here, so if you talk from here, it is minus 2 means you have this point as minus 2 and minus 5. So if you join all these points along with the vertex this way, yeah, it will give you the final graph. So this is the graph for y equals to minus 2 x plus 1 minus 3. So learn in both the ways, but while solving the problem, see which one is working well for you, then you can adopt one of the method that works better for you. Now here you can also further analyze this graph, as this is the final graph now. So here also you can see the graph are the same, and by both the methods, and you don't need to make all these things here. So once you become used to of drawing the graph, you can just take one point and then go to the final step, just like in here. So what other features you can discuss about the graph? For example, at this time, as x is greater or equals to 0, so you can write here like y equals to, you can take this bracket, minus 2 x plus 1 minus 3 for x is greater or equals to minus 1 means, x plus 1 is greater or equal to 0 means x is greater or equals to minus 1. So this is for x is greater or equals to minus 1. And then another time you have to write one time plus, another minus, you write minus, so minus times minus becomes plus. So it is, another time it is 2 times of x plus 1 minus 3. So plus minus, the changes of plus minus sign we make under the absolute sign only, not for the other part of the function, not for the additional part of the function. So this is valid for what? You can see here, this is valid for x plus 1 is less than this, so it is x is less than minus 1. So you can write here for x is less than minus 1. You can also see the situation in the graph. for x is greater or equal to -1, this is the graph of the function whose gradient angle is obtuse. So you can see here its gradient angle its gradient angle value is greater than 90 degree about the x-axis. Yes, and for this you can see this is the graph of the function 2x plus 1 minus 3, and this graph is valid for where -1, the numbers in the x-axis which is less than -1. So in this way also you can express your graph. So that's all for drawing the graph. And now if you are interested, you can try yourself. I am giving you some of the examples to work yourself after you watch this video. I can, so it's what question number I have marked is question number 6. Yeah, so you can try these questions like this is 7. You can try question number 7 like y equals to 3x plus 2. Question number 8, you can try y equals to 2 times of 3x plus 2 plus 1, and yes, like such. And also I can think like y equals to half minus 1 by 3 x plus 1. Question number 10, if you would like to try it again, then it is, you can write here like minus 3 x by 2 minus 1 plus 1. So try this question as your practice work. Now this is important for us when we are learning the graph to go through the graphic software. Although this is not allowed in your exam, but you can test your graph whether or not you have drawn the graph is correct in order to build up your confidence. So what I will do here, like I'm not going to type all the steps here. I will type this function directly into my graphic software. So here I will start with -2, then absolute value sign. Yes, this is absolute value sign, and then x plus 1. I'll go out of this absolute value sign, then finally this is 3. Now you can see the graph. Yes, you can compare both the graph. You can see here, compare this is the final graph, so it gives you only the final graph. So our final graph is correct. Let's check some of the point. So vertex is -1 -3. Let's see whether or not it is -1 or -3. Yes, you can see that it is vertex is -1 and -3, and also the point on the y-axis. So let's check the point on the y-axis. This is the point on the y-axis where the graph crosses it. So if I read this point, this is 0 -5. Here also we have 0 -5. And on the side parallelly, if you see here, I don't know. Yes, so 0 -5. So it is up to here is -1 unit. So if you go left another 1 unit from this line, this we can say the line of reference. So it will be -1 and -1 -2. So another point will be -5. But at this time, a domain is not fixed here. So domain goes from negative infinity to positive infinity. So you can just keep some extension in this line. So in this way, you can check your graph by using any graphical software. So that's all for now.